Hello, I am Gopakumar. Welcome to your math tutor. Here we focus on helping you to solve the problems in engineering mathematics in the easiest possible way from an exam point of view. If you are interested in theory, then check out NPTEL. Evaluate integral 0 to infinity x square by x square plus a square into x square plus b square dx. In case of contour integration, generally the most critical aspect of solving the problem is identifying the type of the given question. In this question, we have polynomial in numerator and denominator in the form f of x by g of x, and the power of the denominator is greater than the numerator. Also, limit varies from 0 to infinity. So it is the question of type 2. Another important thing to note here is, if the question is of type 2, we consider only above real axis poles, that is, we have to find the residues of only positive poles. Before we go further into the video, let me ask you a question. Are you familiar with poles and residues? If the answer to the question is no, then you have to watch the previous videos on Cauchy's residues. If the answer is yes, then good. Let's move forward. Here f of z is z square by z square plus a square into z square plus b square. Here the poles are given by z square plus a square into z square plus b square equal to 0. Let us equate z square plus a square equal to 0. Then z square is equal to minus a square. Then z is equal to plus or minus ai. Therefore, we get the poles z is equal to ai and z is equal to minus ai. Let us equate z square plus b square equal to 0. Then z square is equal to minus b square. Z is equal to plus or minus bi. Then we get the poles z is equal to bi and z is equal to minus bi. Here f of z is z square by z square plus a square becomes z plus ai into z minus ai, and z square plus b square becomes z plus bi into z minus bi. In type 2, we find the residues of only above real axis poles. Here z is equal to ai and z is equal to bi lies above real axis. Find the residue of z is equal to ai. Use Cauchy's residue formula. Limit z tends to a z minus a f of z. Substitute pole ai in formula instead of a. Then limit z tends to ai z minus ai. F of z is z square by z plus ai into z minus ai into z plus bi into z minus bi. Cancelling z minus ai terms and substitute z is equal to ai in the remaining terms. Then z square becomes ai the whole square by z plus ai becomes ai plus ai, and z plus bi becomes ai plus bi, and z minus bi becomes ai minus bi. ai the whole square is equal to minus a square by ai plus ai is 2ai, and ai plus bi into ai minus bi, which is equal to ai the whole square minus bi the whole square. Minus a square by 2ai into ai the whole square becomes minus a square minus of bi the whole square becomes b square plus b square. Cancelling a terms, then we get the residue of ai as minus a by 2i into b square minus a square. To find the residue of z is equal to bi, use Cauchy's residue formula. Limit z tends to a, z minus a, f of z. Substitute the pole a is equal to bi in formula. Then limit z tends to bi, z minus bi, f of z is z square by z plus ai into z minus ai into z plus bi into z minus bi. Cancelling z minus bi terms and substitute z is equal to bi in the remaining terms. Then z square becomes bi the whole square divided by z plus ai becomes bi plus ai, and z minus ai becomes bi minus ai, and z plus bi becomes bi plus bi. Bi the whole square is equal to minus b square divided by bi plus ai into bi minus ai, which is equal to bi the whole square minus ai the whole square, and bi plus bi is 2ib. Minus b square by bi the whole square is minus b square, minus of ai the whole square is plus a square into 2ib. Cancelling b terms, and residue of z is equal to bi, which is equal to minus b by 2i into a square minus b square. Using Cauchy's residue theorem, 2 pi I into sum of residues, then integral minus infinity to infinity x square by x square plus a square into x square plus b square dx is equal to 2 pi I into sum of residues r1 plus r2. 2 pi I into residue of z is equal to ai is minus a by 2i into b square minus a square, and residue of z is equal to bi is minus b by 2I into a square minus b square. Taking 2I common from denominator and minus a by b square minus a square is multiplied by numerator and denominator by minus 1, then we get a by a square minus b square minus b by a square minus b square. Cancelling 2I from numerator and denominator and taking LCM, we get pi into a minus b by a square minus b square. Since a square minus b square is a plus b into a minus b, and cancelling a minus b from numerator and denominator, we get pi by a plus b. Integral minus infinity to infinity x square by x square plus a square into x square plus b square dx is equal to pi by a plus b. But in this question, limit is given as 0 to infinity. Therefore, to change the limit from minus infinity to infinity to 0 to infinity, we divide the answer with 2. Then we get the answer integral 0 to infinity x square by x square plus a square into x square plus b square dx is equal to pi by 2 into a plus b.